So after last night's major storm, we have some wonderful examples of how the Earth is always changing. Here's one. It's not really the Earth, but you can definitely see the water flowing here. We're going to get some examples of that in just a moment with what it does to rocks and soil. So as it rained last night, the water from the storm slowly came down the sides of this wall right here. And here you can hear it and see it just dripping non-stop right down here. This stuff is being weathered. Now weathering is a super slow process, and since that's concrete and rock, you're not going to see much of a difference. But you can be sure that this part of the ramp right here definitely is more worn down than the rest of the ramp, because whenever it rains, water is constantly hitting right there. So from last night's snow that hit, you can see how the water here is still frozen. The physical weathering that's happening comes from the temperature changes. So during the day it's going to heat up. At night it was cold. When it's cold, objects expand, they get bigger. When it gets hot, they get smaller. That process of things getting bigger and smaller slowly weakens the object. In this case, the ground, or potentially the cement, or anything that's covered by the water that eventually freezes. If that water finds a crack anywhere in concrete or rocks or soil, it's going to get in there, it's going to freeze. When it freezes, it expands. That pushes open the gap. Now that process is really slow. It's not something that you're going to see like all of a sudden all of the rock walls and rocks around us are just exploding because it froze. It doesn't work like that, but it does slowly but surely over time cause things to weaken through that process. So here you can see an example of erosion through one of the activities that we're doing in our science unit, and you can see where the water got poured in here, and you can see how it simulates the erosion process. And you even have kind of an alluvial fan forming at the bottom of the slope. We're going to go take a look to see how that happened in real life right around here at school right now. So it was a really strong storm last night, right? And as the water accumulated down this slope it came, and just like you saw in your investigation on it, it eventually starts to collect in certain places and eroded the side of the hill here and collected and kind of spread out into an alluvial fan. This stuff right here wasn't where it was. It wasn't here yesterday. It was further up the hill. It slowly kind of saturated and then spread out. And you can see it's all collected down here. And look at that. That wasn't there last night. That was from the process of erosion. And as it hits the bottom of the slope and starts to flatten out, like you can see here, all of this mud collects because it eroded. So here you can see the water that's dripping from the covered walkway. And you can see how it collects in different places. Well, this is one of the places that it collected. As it hits a slope, it starts to collect. Wow, it's pretty muddy here. Check this out. Probably shouldn't even be walking here. I'm making the erosion worse. As it collects, it starts to fan out. As it fans out, we call that an alluvial fan, because as it comes to the area where it's flatter, it spreads out, it brings all of that dirt that was up there down here. And that process of erosion becomes much more dramatic when you have more water flowing, like in a big thunderstorm like we had last night, and when you have a bigger slope like you have here versus what you have on the flat playground. There wasn't much of an impact there. But anywhere around school or around these mountains or around the world, when you have a slope and you have water erosion happening, if that slope is greater, if it's steeper, you're going to have more erosion. If it's less steep, it will be less erosion. If it's flat, the erosion will be even less than that. Glad I was able to get my coffee cup in the video. Other things that you're going to find is the impact of plants on erosion. And here you can see how the slope doesn't have any plants in this section. The erosion is going to be much more dramatic where there aren't plants. Where you see the grass over here, you're going to notice that the erosion wasn't much. It held it in place. The roots of the plants hold it in place. Here, you'll see more and more erosion. The dirt is a lot softer here because there's no plants to hold this stuff in place. So when the water hits this, it has a greater impact with the erosion. Now, this impacts all of us because we need to think of the plants as a great defense against erosion. So when you guys are playing in the flower beds and up in the plants, you need to understand that if you kill those plants, if you destroy them, it ends up increasing the impact of erosion. The same thing happens when we go into a forest and we cut it down. The trees, the plants that were holding the ground in place, when they're gone, the erosion in that place is going to get a lot worse. So our job as humans is to try and figure out how to manage our resources in a way that doesn't negatively impact our planet. We'll be talking a lot about that in our unit.